Another principle of learning has to do with the course climate. In particular, students' current level of development interacts with the social, emotional, and intellectual climate of the course to impact learning. Now, everybody knows that you want to have a class where the students feel comfortable to ask questions, and they don't want to feel intimidated. Okay, we'll assume that's the basic level. So what I want to do is go beyond that and say, what more can you do than that? One of the topics I'll start with is social climate, team-based learning. And this is a particular strategy that you can use. And so in team-based learning, students can work together. Ideally, they're sitting around a table, and these are students here sitting at the table, and they're discussing problems. In typical classes here, I just have them turn around and talk to each other. But in this particular case, they can discuss things. So it's been tested what their performance is like. If you give them a question and you have individual responses, and it's a multiple choice questions, their answers might be all over the place, some correct, some incorrect. If instead you have them talk about it and say, okay, here's the problem, let's talk about it. After the group discussion, then you have them individually respond. You're going to get a more consensus around the correct answer. It's that ability to talk to each other and collaborate and to discuss it that helps them to learn the material better. So what the principles here have to do with practice, you're giving them practice on it. The social climate, you're allowing them to work together. And targeted, timely feedback to students, because they're able to discuss their concepts, their understanding with other students, they get immediate feedback on what they do and don't learn. The intellectual and emotional climate, in a previous presentation, I showed this, where we're matching, looking at the cognitive skills and how they match with the challenge. And what we said is you wanted to be right in this range right here, the happy zone, where you're pushing students a little bit beyond their cognitive skill on the challenge that you're giving them. Too much, and you're going to get anger. Too little, you're going to get boredom. So you want to be right in this zone. And to look at this concept a little bit more deeply, we want to look at the Yerkes-Dobson curve. And this shows specifically the performance versus the amount of stress. Now, originally this report was done, this study was done in terms of amount of mental arousal, but then also it's been redone in terms of stress. So basically, if you've got a low stress, their performance level is going to be lower, or low mental arousal, it's going to be lower. If you push them further, or if they're stressed more, then their performance starts going up. That's when we're kind of in that happy zone. And there's an optimal place where you're pushing them and stressing them just beyond their comfort zone. You get a good optimal. But if you push them too far or you stress them too much, the performance level goes down. And there are actual physical things that happen to the brain when this happens, chemical reactions that go on that inhibit learning and performance. So the reason I bring this up in terms of, I want to discuss it in terms of tests, because oftentimes people do tests where they're very timed, and timed is important. And so what they're doing is they're operating right here. Students that are a high level of stress, so tests and exams, if students that are a high level of stress, because the time is such a critical issue in that particular test, then you're testing them really on this curve as opposed to their optimal performance in the class. So to avoid that and test them more along what their best performance and their best knowledge is, then I have a rule of thumb, which a lot of other people and other places use as well. The test should take you no more than a third of the time allotted to the class. And why is that? Well, all you have to do is mechanically work through the test. You know the answer. You don't have to think about it. The other 2/3 of the time allows them to think methodically about it. You want them to have that chance to think systematically and methodically about what they're doing and not to be under a high stress level. So this is a rule of thumb so that you're more likely to be testing in this region as opposed to this region. Now let's talk about the emotional climate. Okay, as I said before, you don't want a class where people feel intimidated within the class. But what about other things, other factors? And I'm going to talk specifically about curving grades. All right? It's something that we do all the time in engineering, but is it a good thing? The most common high school grading system is what we would call a straight curve right there. And in fact, at the lower division Georgia Tech classes, English, physics, math, CS, they have that same policy. They don't curve the grades. In engineering, we curve grades. And why do we do that? Well, a lot of people say it gives us flexibility in curving, because if given a test, we don't want to be giving all C's and D's because everybody did poorly on it. So we want to have some flexibility. But the cons, there's a number of cons to doing this. One is a questionable merit metric. Okay, what are you actually grading them on? You're giving them a grade not based on their mastery of the material, but rather on how they did compared to other people. Well, among students, there's a perception of fairness. You hear it all the time. You know, I felt like I knew the material, but it wasn't tested on that, or I'm not tested based on, or I'm not graded based on whether I know the material or not. It also lowers the tendency to help others. So students will often work together in a study group if they're matched in ability, but they don't want to help others who are below them. It's like they don't want to tutor others because that, it might mess up the curve. Increases uncertainty. And this is something a lot of students feel frustrated about. They don't know where they stand in the class. And it's a lot of uncertainty, which lowers expectancy for them, which lowers motivation for them. So how do you develop an engineering test where you can use a straight curve like this without having to lower the curve or curve the grades? Well, first of all, on my grading, on my syllabi, I always say, I state it something like this. This is a very common thing. I say, this is the grades, this is what they should expect. Curving the grades is very unlikely. So in that particular case, if they want to help other people, and I tell them, if everybody gets above a 90, they'll all get A's in the class. I don't care, because that means they master the material and they know the material. I'm not an easy grader, but if everybody shows they understand the material, I'll give the grades. And then in terms of creating tests to get that, because tests are an important part of what our grades are made of, I have a certain strategy for how I create tests. And I think of it in terms of competency. Competency means they're competent in the material. They should get a C. Mastery means that they know it better. Maybe they should get an A or B. So to test competency, I say, all right, I'm going to make 75 to 80% of the test based on problems exactly like what they've seen already. So problems very much like the homework, the worksheets, and class examples. Those students that can work problems like that, then they should get a C in the class. They've shown that they're competent in the material. Now, what about mastery? So for the other 20 to 25% of the material, I make it more difficult problems or shorter, lower problems, credit problems. So this particular part is, do they know all the nuances of the course, like the lower level, the less important topics, but more detailed sorts of things? Or can they work harder problems? And if they show that they can get credit here, then they deserve an A or B in the class. They master the material. So when I do this procedure for creating the test, my averages always just turn out to be in like the upper 70s for that. And then I don't have to grade. I don't have to curve the test or the course. So to summarize, these are some of the tactics that you can do, to address some of these principles of learning. Collaborative learning, with students working with each other in class or out of class, that's a social climate. Also, collaborative learning means they're discussing the problems with each other. They're getting more practice and timely feedback when they discuss it with each other. They figure out what they know or don't know. Appropriate test or project length and format, the amount of time that you give them and the challenge that you give them. And it's an intellectual and emotional climate and motivation that you're really you're not stressing them out too much. You're pushing them just beyond their capability, and you're being able to have them work at a peak performance or demonstrate their knowledge at the peak performance level, not under high stress levels. Competency and mastery-based learning, that is when you're really testing them on what they know, not what they know compared to somebody else in the class. Do they master the material? If they do, they should get the grade. And also motivation that if, for example, looking at the curving on the class, if you curve the class, they don't know where they're standing. But if you don't curve the class, you say, this is what I'm expecting, then they know where they stand in the class and what they have to do. All right, thank you.